live?
We will be in a minute. We are on.
Oh,
but
nice.
On the YouTube audience, we've got 14 people coming in here. We are live.
Welcome, everyone.
Yeah. We will give a minute to let people clear in. Welcome. This is a session with, I'm Dale Doherty of Make Magazine. Oh, wait a minute. Somehow. How does that happen? I gotta go turn that off. Okay, there we go. All right. That's the first time I've done the streaming myself. So, but welcome to those coming in here. Our attendees here. I'm Dale Doherty, and I'm with Make Magazine and producers of Virtually Maker Faire. I'm delighted to be here with Joseph Prusa of Prusa Research and designer of the Prusa Shield. We will be talking about that. And I have an interview rather, that I did yesterday morning at about the same time with Adrian Boyer of RepRap fame. And, one of the things I really wanted to cover was how the idea of 3D printing and the actual 3D printers getting in more and more people's hands enabled the response to COVID-19, that people had a tool they could do something with. And many of them had them at home, or in some cases they had them in maker spaces. And when they closed, they brought them home. So, in many ways, that idea that these kind of machines could be made and could be used by people like makers originates in the RepRap project. So I'm going to start with by sharing my screen, and we're going to have a 15-minute interview with Adrian, and then we'll come back and talk to Joseph. Okay.
All right.
So let me get that up. Okay.
I used to be an academic at Bath University, but I retired 8 years ago, and so I now live about 30 kilometers from there, but not too far away.
All right. Well, I'm so glad to have you to talk to you today, and we're doing Virtually Maker Faire. I wanted to record an interview with you. I think you're one of the founders of a movement that makes this kind of maker response to COVID-19 possible, because you had this idea that 3D printers belonged in the hands of lots of people and you wanted to make it affordable. So we're talking about the RepRap project, which started in 2004.
Yes, okay, yes, I certainly started it, and that was one of my intentions. The secondary intention, I did want it to go to the hands of everybody, but my primary intention was to make a machine that could copy itself.
Right. Talk about why 3D printing? Like, what led you to that, to focus on it?
It was, the sequence of events was a long and a short one. So the long sequence was that I've always wanted to make a useful self-replicating machine ever since childhood, so 60 odd years ago. In about the year 2000, my university acquired some 3D printers, and I knew about the technology before, but using them was a real revelation. Suddenly I realized that this was an incredibly powerful manufacturing technology. And given my long-standing ambition to make a self-replicating machine, it seemed to me that this was the most likely technology that would be able to self-replicate. So that's the reason I chose 3D printing as a basis for self-replicating.
But those 3D printers at the university were industrial grade. Is that right?
Oh yes, the Stratasys 3D systems. Those, they cost $1/3 million. Right. What the cheapest one at the time I started cost about $50,000.
Yeah. So a key part of RepRap was to make it an open source project, something that could be shared, and not only allow low cost replication of 3D printers, but using the 3D printer itself to build itself. That's the self-replicating side of it, right?
Yeah, yes, indeed.
Yeah. So the first model was Darwin.
Yes,
is that right?
Yes.
Okay.
Designed by me and my research student, Ed Searles, now Dr. Ed Searles as a result.
That's great. And how hard was it to do that?
How do you quantify how hard something is to do?
It was something nobody had done before, so it had to be hard.
It was 7.3 hard. No, there were two aspects to the answer to that question. The first and most obvious one is that there were no serious impediments. That's to say, we never reached a point where we ran up against something which we really couldn't solve. But there was a lot of detail to work out, which was done not just by me and indeed by Ed, but by lots of volunteers as well. And so in terms of the amount of work to be done, it was considerable. So it was hard in that respect. But technically, it wasn't too difficult because all the technology existed. It just had to be put together.
Yeah. And then, you know, I guess as it started to go beyond your university out into the hands of the community, but what was it? What did you? I mean, to open source something isn't necessarily understand where it goes, right? So
no, of course, it's to relinquish control of it to a greater or lesser extent, and I was acutely aware of that when I decided to open source it. But the reason I decided to open source it was because of the logic of self-replication. It didn't really have anything to do with the fact that it was a 3D printer per se. Any sort of manufacturing machine would have led to the same logical conclusion, which is if you make a machine that copies itself and you try to patent it or copyright it or restrict it, then basically you're saying to people, here's my self-copying machine, you can't copy it, which is crazy. So I open source as a way to allow people to copy the machine without restraint, and that seems to be the way to go.
So again, I think sometimes, I certainly would expect there are people listening to this that know little about RepRap, but it really is the parent in many ways of many commercial 3D printers, especially in the maker in the maker community. We talked about MakerBot, LulzBot, Prusa, many of them, you know, they at least cut their teeth on RepRap.
Well, MakerBot literally, because one of the three founders of MakerBot, Zach Smith, was a long-standing volunteer on the RepRap project, and that's how MakerBot got going, using the technology that he and I and other people, my student whom I mentioned, Vic Oliver from New Zealand, and lots of people, too many people to mention in this, but that technology went straight into MakerBot. So, and as you say, the other companies like LulzBot and Prusa and so on. Joe Prusa again was involved in developing RepRap machines before he founded the company. So
and you know, in some ways, the idea that the plans were easy. I mean, this is one of the things we see even in this COVID-19 problem space is open source specifications even, or instruction sets allow people to build things when they need them.
Well, yes, indeed. We've mentioned Joe Prusa. His company, I'm not sure if he personally designed it, put out a face shield, of course, that's 3D printed. And we, by which I mean my personal little RepRap company, have been printing those for use by healthcare workers and care workers in general in the UK. And that's been an effort that's been organized nationwide. We didn't organize it. We merely volunteered as one of the printing people to help along.
Yeah, a producer.
A producer, Prusa. And they've made hundreds of thousands of face shields, of which we made a fairly small number, but nonetheless, it was a small contribution to a big whole.
Right. And that's what I find fascinating, is the fact that over a 10 to 15 year period, maker spaces and makers have learned to use 3D printers. And even though in at least in the US and many other parts of the world, the maker spaces got shut down, closed because of the the pandemic, people took the 3D printers home and began making face shields or the components for face shields at home and figuring out. But you know, it's really a world of distributed manufacturing, which was one of, I think, one of the things you saw in this is not just a big manufacturing plant producing something that's centralized in one place, but something that's widely available throughout the world.
Yes, I mean, there are several aspects to that, I think. It is something that I anticipated. And of course, one of the characteristics that a distributed system such as that which we've been describing has is that it's very responsive. For example, if the design changes, you perhaps got thousands of people all producing these objects, and they can literally change in half an hour to the new design. Whereas to take a comparative technology which is traditional for producing the same thing, say injection molding, if you're going to injection mold face shields, you have to build a whole new set of molds for doing the injection molding, which is first of all very expensive, and secondly takes weeks quite commonly to do. So you've got that enormous responsiveness. Now, the thing about 3D printing, of course, and in general, is that it's a comparatively slow process. An injection molding machine will make an object in a fraction of a second. A 3D printer will take half an hour to do the same thing. But of course, if you've got enough machines, they're effectively very fast, because one injection molding machine might be the equivalent, I've never done the calculation, but obviously 500 perhaps 3D printers, whatever it might be. So if you've got those 500 3D printers, in particular, you've got 500 people with them in their attics, as I say, they can respond much more quickly than the person running the injection molding machine to a change in the requirement.
Yeah, and I think one of the things we see is where the prototyping and production phase kind of, there's at least a point when, you know, these communities were producing face shields and things, getting feedback, going back and making the design, something that if you said, here's a design, it can only be injection molded, it can only go, and it has to be exactly replicated in each way, you wouldn't have those local modifications. And it turns out, you know, in talking to healthcare professionals, they wanted different things. And one of the problems is when you ask, they tell you, right? And
but as you point out, it's not such a problem for this particular form of distributed 3D printing, because it can respond so very quickly. And as you say, you've got this large number of variations, which effectively puts you in the same position that life is in with Darwinian evolution. The reason why it works is because reproduction gives you exponential growth, and exponential growth means that you've got an awful lot of tries to select the right one from. Most of the people's modifications for the face shield design, I'm sure, turned out not to be as good perhaps as the one or two that finally succeeded. But that didn't matter, because those one or two then got spread out across the entire population of makers.
Yeah, and I think, I mean, I wrote an article about the Montana mask, which is a 3D printed respirator mask with a replaceable filter, 2 parts. But you know, the interesting thing was, yes, you know, a process developed by which some of the modifications, improvements were added back into the, you know, design, and then they said that's the new one. And but the variants remain out there, and they can, like you said, they can fill different niches. And it is got kind of a good analogy to evolution, that we've kind of traditional manufacturing is like cloning the same thing over and over and over, and 3D printing is actually enhancing the variety of the ecosystem.
Yes, so of course that's the same thing that happened in the development of the RepRap project itself, because we started off with, as you mentioned, the very first design, the Darwin machine, but quickly there were tens and then hundreds of different competing designs, and some of them were terrible, but one or two of them turned out to be really good, and those are the ones that succeeded.
Yeah, I mean, it's a really good analogy, especially in when something is relatively new. If you go to an airplane museum, you see how many different ideas about flying people had. Like, well, where do we put the pilot? You know, where do we put the wings on the fuselage? You know, and they tried all those different things. You know, and then it kind of narrows down and said, this is what works. and in some ways that happened in 3D printing commercially too. There were lots of even commercial 3D printers. It seemed to me like every country had 1 or 2 or 3 different companies. Then, you know, to some degree, I think a sort of over-enthusiastic investment sector said, oh, this is going to be huge. And so they got in, like, you know, and various things happened, like Stratus is buying MakerBot. But it settled back down, you know, it settled back down to a fewer number of those, but many of them had figured out the same problems, and so it stabilized.
Yeah, I definitely see the same thing, and that doesn't have anything particularly to do with makers or 3D printing. I think that phenomenon you just described, it's, I think, go back to the history of the railways or whatever. You see that everybody was running their own personal railway into their back garden in the 19th century, but quickly that all got consolidated, and there were fewer companies that were bigger, and they settled on a gauge and all the rest of it. You know, so the development of every technology. I mean, we've got this weird thing where every chip you buy almost has a pin spacing of 2.54 millimeters, which is a kind of crazy measurement, except when you realize that it's 1/10 of an inch. And so you've got these things become standards, even though they sort of don't seem to make sense when you look at them at the end of the process, rather than regarding the process looking at the history of the process.
That's great. Well, I think that's the perspective I want to add here. But it's also that these things take time, right? There's, you know, this 10 or 15 years has been a period of experimentation, but it has also enabled people to be able to do something. So many have said to me, you know, and it's kind of interesting, you know, the Montana mask, the 3D printing, the design and the printing of it was done by someone graduated from college in microbiology, but he took an engineering class in high school. He learned 3D printing. He kept it up just as an interest. And so when someone said, can you do this? He said, sure, right? And so, you know, expanding the capabilities of people, humans, to do this is, I think, one of the big stories here. And it is a pretty clear idea that 3D printing allowed people to create designs, make them real, get feedback, and really get them into the world, make something real, take an idea.
I mean, MakerBot started with Thingiverse, but there are now lots of websites where people put up designs for people to download for free, and of course GitHub is absolutely full of 3D printing designs. I have no idea how many there are out there. Someone perhaps should do a survey, but it must be millions.
Exactly. Well, I'm recording this interview today, but we'll be talking to Joseph Prusa tomorrow.
Oh, right. My best wishes.
Okay, and it'll probably be, if it works, recorded in the same, or produced in the same session, so he'll hear you. I thought, do you have any message for Joseph?
Oh, well, I give him my fond greetings and congratulate him on the successful design of a face shield, which seems to have gone right round the world. So really well done for that. I have no idea how many lives it saved, but clearly it's more than one. But even if it were only one, it would have been worth doing.
Absolutely.
Okay, I'm back. Thank you to Adrian Boyer for the interview. Joseph, are you there?
Yes, I am here.
Okay, good. Well,
I need to send a text to thank him.
Yeah, it's kind of one end of the spectrum, and historically, right? And you're you know, now driving this forward. So first of all, welcome to our guests, attendees, and those on the live stream on YouTube. But you know, you know, RepRap was something that you were involved with, and then you started your own company. But I think as much today, we want to focus on the amazing work you've done in creating you know, one of the few designs that has a name on it that people actually, you know what it is. So congratulations to you on that.
Yeah, I mean, I wouldn't say, I mean, I was part of RepRap project before I started the company. It doesn't have to be like separate, because I think that the printers we make are still part of the RepRap. because RepRap stands for Replicating Rapid Prototyper. And as far as I know, we are still replicating the printers. And I think I'm pretty sure that we have the largest 3D printer farm on the planet, which is also why we were so eager to look for things we could use it for in this world of COVID-19.
Yeah.
So should I start with like a basic story how we got into the face shields?
Mhm.
I mean, we were doing a lot of preparations around the company even before our government started, because we are globetrotters, so we know how the air travel works. It was I was pretty sure that it's going to get everywhere. So we were starting to do a lot of things. I can show or paste a link into the discussion about some of our measures, which I think are very helpful even now, because it is a marathon. But we were looking how to help more than just inside our company. So basically, I was looking around what we could join or create or push forward. And mostly at that point in the 3D printing community, there were respirators being printed. But honestly, I still to this day don't think it is that good of an idea after a brief analysis. Because I mean, if you are, I mean, I'm pretty sure that they can be printed safely, but in a very controlled environment. And I don't think people at home, if they are doing one or two, can do the QC. And the designs, mostly what I saw, they are very cool, but the thing about respirators is that, I mean, you print it and it looks super badass and it seems like it has to work. But there's the thing, I mean, you cannot verify that it seals properly everywhere. And if it doesn't seal, it is as good as cloth mask, which by no means are bad if they are used properly. But if these would get into to the hands of medical professionals without the proper QC, I think it might be more dangerous. So this got me thinking about what we can do safely. And at one point, I saw a design which, let me find so I can properly credit, on GrabCAD by Gizeh Triana. You can find it on our blog post. So there was, I would say, proof of concept of face shield. So at that moment, I knew that that is the thing we want to do, because there's no such thing like false safety with the shields, because they are, I would say, they are like self-validating design. I mean, if it holds the visor in front of your face, you know that it works, it helps. And it is not a replacement for the traditional respirators and goggles, but it is an addition. So I decided, or my thinking is that it is safe enough for people to print it globally. So at that point, I had the team at the company ready. Even though we didn't know what we will be doing, we had people assembled and basically ready on the starting line. And at that point, when we found out that we are going to make face shields, we started. And so we did the first designs. They are still available on the prusaprinters.org. And I pulled some strings and got contacts for the Ministry of Health in Czech Republic, and I got in touch with people there, because I knew that if we start doing something, we would love to share it and do our homework properly, to do as much, because we have a large team, so we wanted to prepare as much as we could. And the same day we were basically testing it with the doctors, and there it took us like 3 or 4 iterations, And in 4 days, we finished our first batch of 800 pieces, which we were distributing. So from my point of view, what was very important to do the verification, because I mean, you don't want to make something which is not compatible with all of the other gear people are supposed to use. I mean, it might be from the full body suits to the indirect ventilation glasses, different types and different types of respirators. So we checked all of that. We checked the coverage if it is good enough, and we started. We also prepared the assembly manuals, how to use it. We shared that with everyone, and also how to make it safely, because especially at the beginning, not that it doesn't matter now, by no means. I mean, we are still not through this at all. Just a few days ago, there was 106,000 new cases in a day, which is the most since the start. So don't get fooled that when some countries are easing restrictions, that it is getting over. So that is very important if you are printing if you are printing something. So the best rule of thumb is that if you are making any equipment for other people, act as if you are infected. So if you are printing something or making something, always get a pair of fresh gloves, wear a face mask, sterilize everything. And for example, when printed part is finished on a 3D printer, it is sterile because of the high temperatures. So just take it and put it in a clean bag and just zip it, so you don't destroy it. And I think these things, together with the verification of the health ministry, when we put it out, I think that was one of the reasons where how it got trusted by people. And in just a few days, I mean, I think it was 5 days until we saw our face shields printed by Ford on US national TV. So that is, I would say, the beginning of the story. And I don't know if how we will do it, if we want to say some questions.
Well, let me see. Jan Wegener is in the audience, and he is, looks like from his chat, he's a 16-year-old. Jan, I'm going to try to bring you on as a panelist to tell us a little bit about what you did. See if this works. No, I didn't. May have hit the wrong person there, but we'll see. Jan, there you are. Hi.
Hi.
How are you? So can you tell us what you've been doing? And first of all, where are you from?
I'm from Germany, so
okay.
My English is not the best.
That's okay. You're doing great.
I'll do my best. Okay. Yeah. So from, I don't know, 4 weeks ago, a friend and I started printing the Prusa face shields, and yes, so we gave them to local doctors and the hospital, the teachers, and they all loved it, and they sent us pictures. And yeah, we were in the newspaper, and it was amazing because we are, I don't know, my city, there are around 50,000 citizens, or 50 to 70,000, and there came so many people with printers and Prusa printers, the Mark III S, that's okay, you spread it to the whole world. And we shared the G codes, and yes, that was cool. And we ordered the filament together, and we have, I don't know, around 20 printers working. Wow. And used, yeah, the many for the bottom parts and the bigger printers for the normal parts. Yeah.
Yeah, thank you. I just wish that I could have, if there is a way how to find out how many were actually made all together. Yeah. We already made and donated for free over 130,000 here in Czech. Not all of them are printed, because actually I was thinking that we will be doing it for 2 weeks, 3 weeks maximum. And after that, the traditional forms of manufacturing will pick up. but I was kind of wrong because no one was like really picking it up. So we invested into injection molding. So most of the shields now are injection molded because we knew at that point that we will be making them for a long time, and so we set it up.
Right.
But
Jan, do you have another question or anything you want to ask Joseph, or I'll put you back in the attendee box here.
Okay, it was, I can tell you one, it was a dream to have a call with Joe Prusa, because I can say that's, okay, you're my favorite person. Okay, it's.
I will be blessing. Thank you, Jan, very much, and
Thank you.
And thank you for the good work and helping others.
That's great.
Yeah, thank you.
All right. Well, good. Terrific to see what people do. Go on. I'm sorry to continue.
I would like to continue because at that point, when we knew that it will be for a long haul, we started to do more of the homework for the rest of the community. So I don't know if we will get into certification, but one thing I'm very proud of, which is useful for all of the 3D printing community. Let me try to share a screen. All right. So do you see it? Do you see the screen, everyone? So basically what we did, especially in the home desktop 3D printing, there is like, it is not safe. You cannot disinfect it properly. And there was not much need or push into doing these tests in the lab. But I thought that this is a good moment to actually verify. And what we found out, we actually had some labs here in Czech Republic to test how to disinfect FDM desktop, like semi-professional printers, how you can disinfect it. And we did that with live COVID. So you can find these things or the disinfection results and how to disinfect 3D printed parts on our knowledge base. And that is pretty amazing because we can use this in the 3D printing community for the rest of the times until 3D printing becomes obsolete, which I don't think will happen very soon. So you can test, you can check this out. So that is, I think, very helpful. So I'll stop sharing the screen now. And do we have any other, do we have other questions?
Yes, I think we do. I just asked David Martin if he'd like to come on. I'm gonna, well, actually, I'm no longer the host here, so one of my Maker Faire people is gonna have to help me.
I'm not the boss of the Zoom call anymore.
Well,
right?
I had to get, for some reason, this live streaming, I had to change it to someone here. Jillian, are you on here? Just a minute. Well, let me ask the question while we do this. So actually, David, who I was going to bring on, he said they're using Prusa printers at Modesto Junior College to print PPE. He wanted to get more Prusa printers though.
It is interesting times for us because even before we did the shields, we started to have a big race of orders, and basically for a couple of months we now have like double. It turns out, I guess, that 3D printing is very useful in this, I would say, post-apocalyptic world. And I mean, it wasn't, in retrospect, I would say that after some time I realized that this actually really showed the world what 3D printers can do. And a lot of people are now believing that it might be the future, because I mean, even though that most of our users are using it for work and to make stuff, it doesn't mean that if you work with 3D printer, you usually don't have much time to share stuff online. So that means that most of the people